Hi, welcome back to my channel, Physics Form 4 KSSM. Today we continue Chapter 2 on topic 2.7, Impulse and Impulsive Force. In this video, I will discuss one learning standard, that is communicate to explain impulse and impulsive force. Look at this situation. A parachutist is trying to reduce injury upon landing on the ground. Can you suggest a method to land on the ground with least injury? What should the parachutist do? Okay, we have 4 ideas given by 4 different persons. Which one the parachutist should follow? Look at the person A. The man should stand straight on his feet when he lands on the ground. The person B. He should pull his parachute as hard as he can before he lands on the ground. Person C. Oh, he should bend his legs when he lands on the ground. And the person D. The man should lie on his back when he lands on the ground. So what do you think? What should the parachutist do? Okay, let's discuss further in order to give a good suggestion to this parachutist. First of all, we have discussed about Newton's law of motion. In my previous video, I have discussed about Newton's second law and Newton's first law of motion. Look at these 2 cars that involved in this accident. When the 2 cars collide, you can see there is a force act on the green car. At the same time, there is a force act on the red car. The force act on the green car is equals to the force act on the red car. So this one can explain by using Newton's third law of motion, which states that for every action there will be reaction force, same magnitude but in opposite direction. So what is the name of the force that acts during this collision or accident? The force that acts is called impulsive force. Okay, before that, let's look at the term impulse. What is the meaning of impulse? The product of a force and the time the force acts is called the impulse, meaning force multiplied time of impact. Impulse is a way to measure a change in momentum because it is not always possible to calculate force and time individually since collisions happen so fast. For example, if you look at this accident, okay, we cannot measure the time of impact, of course, because it happened very fast. So what we do, we can just look at the change in momentum. So the change in momentum is known as impulse. What is impulse? Impulse, the force symbol used here is J, equals to change in momentum, meaning final momentum minus initial momentum, or also equals to product of force and time of impact. F is applied force, T is time of impact or time of action of the force. Based on the formula, what is SI unit for impulse? You can look at the formula here. Impulse equals to change in momentum. The unit for momentum is kilogram meter second to the power -1. So this is also unit for impulse. Or if we refer to the formula F times T, so we get the unit Newton second. So you can use either one of the unit as a unit for impulse. Just now, I have discussed about force that acts during this collision. The name of the force is called impulsive force. Impulsive force is defined as the rate of change of momentum in a collision or impact in a short period of time, meaning a force that acts during collision. Okay, so this F also known as impulsive force. Impulsive force F equals to rate of change of momentum, meaning change in momentum divided by time of impact. The SI unit for impulsive force, of course, is Newton, or we can write as kilogram meter squared second to the power -2. Normally for force, we just write a simple unit, that is Newton. Okay, so you must be able to state the definition for impulse and impulsive force. Look at this video. In this video, we want to show what happens when we have egg that release from the same height. But in the first situation, we drop it on the floor. The second one, drop it on a foam or a sponge. Okay, so what do you think? What happens to both of the eggs? Let's watch the video. Both eggs release from the same height, meaning they have same final velocity upon reach the ground. Look at the first situation, the egg breaks, but the one that fall on the foam does not break. So we look at again. What happened to the eggs? Make it slower again. Slow motion, this one. So you can see the one that fall on the floor automatically breaks, but the one fall on the foam does not break. You observe the time of impact. Can you compare the time of impact between the two eggs? What is the meaning of time of impact? Time of impact is the time taken from the moment the egg touch the floor or the foam until the eggs become at rest. So we can record the time taken. Because of the time taken is very small, so we can record by using a tracker, for example. So we can record it in form of frames. For example, the egg stops and breaks after one frame when dropped on the floor. For the one that dropped on the foam, it does not break but finally stop after 2.5 frames, meaning 2.5 times longer the time taken. So look at what happened to the egg that fall on the foam. Once it touched the foam, it bounces back a few times until it finally stops. So you can look at the time taken here. The one that dropped on the floor, 4.16 milliseconds. The one that dropped on the foam is 10.42 milliseconds. So this is the contact time required to bring to rest. So the time taken, we call it time of impact. Okay, so what we can deduce from this activity? Both eggs were dropped from same height, meaning both eggs will experience same change in momentum. When both experience same change in momentum, meaning same impulse on both of the eggs. What factor that affect impulse? We look at this situation. A change in momentum in a short time requires a large force. A change in momentum in a long time requires a small force. As we mentioned here, impulse on the eggs, both of the eggs are same because they are released from the same height. Okay, if the time taken or time of impact is larger, the impulsive force is smaller. You can look at the size here. If the time of impact is shorter, the impulsive force is larger. So what caused this situation? It will compare between flow and foam. Maybe we can look at the physical characteristic of the flow and the foam. Okay, as the case of the foam has soft surface. Thus, the longer time of impact is taken. This one will cause smaller impulsive force act on the egg. That's the reason why the egg does not break when dropped on the foam. For the case of the flow is hard surface, thus shorter time of impact. So it will result in larger impulsive force act on the egg. Thus, the egg breaks. So for this situation, we can state that impulse act on both of the eggs are the same or same change in momentum. Thus, the force that produce or act on the egg actually depends on time of impact. As we can see from here, force is inversely proportional to time of impact. Look at this picture. So you can see this is egg that placed in the egg carton, which can prevent the egg from break easily. So look at this one, body injury when someone falls from staircase. What caused the injury? And this a hockey player, okay, by using the hockey stick, able to hit the ball. And then this one case of the piling process. There's a pile driver that knocked on the pile so that the pile can be driven into deep into the ground. So this all explain about the force that act during a collision. We call it impulsive force. So the relationship between force and time of impact can be expressed in this relationship, which is F inversely proportional to time of impact. Increase of time of impact will reduce magnitude of force, meaning when T is smaller, F is larger. Decrease of impact time will increase the magnitude of force. T is longer, F is smaller. Okay? The magnitude of the impulsive force sometimes can be beneficial when the magnitude is larger, as shown in this case. So how to increase impulsive force so that we can knock on the nail easily, so that the nail will be driven easily into the block of wood. So what we do, we need to decrease the time of impact in order to increase the impulsive force. How to decrease the time of impact? So the hammerhead is made of stone or steel, which is very hard. So once knocked on the nail, okay, it will produce shorter time of impact or larger impulsive force. Or we can increase momentum, change in momentum. Thus also can increase impulsive force. The second situation, decreasing the time impact to increase impulsive force. Football, large impulsive force to act on the ball. For example, the footballer swing his leg, okay, backward before kicking to produce larger change in momentum, thus produce larger impulsive force. Look at this one, pestle and mortar. So how this one is made of very hard material, so shorter time of impact will be produced. thus larger impulsive force act to crush the chilies. So hard surface, time of impact is shorter, larger impulsive force. So in this case, we want to reduce impulsive force by extending impact time. For example, in long jump event, sandpit lengthen the time of impact. Thus, reduce impulsive force acts on the athlete. And this one, high jump event, they use very thick mattress. So this piece of soft mattress lengthen the time of impact, thus reduce impulsive force acts on the high jumper athlete. Okay? So we can say that soft surface time of impact is longer, thus smaller impulsive force. Now we want to discuss about the concept of follow-through. Increasing the magnitude of impulse by follow-through action. How to increase the magnitude of impulse? For example, you can see this footballer kick the ball, but the footballer swing his feet after kicking the ball. So this action, like swing his feet after kicking the ball, we call it follow-through action. Same thing, this golfer swing the golf club higher after hitting the golf ball. So this one we call it follow-through action. A follow-through action after strong kick produces a large impulse or large change in momentum. As a result, the ball experiences a large change in momentum and move at a high velocity. So the ball can be kicked further. Same thing as the golf ball. So that's all for this part. I will continue my video on the next part, the next learning standard about solve problem involving impulse and impulsive force, and also formative practice 2.7. That's all. Bye.